Hello and welcome to my YouTube channel Math Solutions. I am Shilpa Joshi and today we will discuss in detail about rational numbers. In this video we will learn about how to write rational numbers in standard form, then how to fill in the blanks, then how to find the pairs of equivalent rational numbers, then we will find the missing numbers, say x, and the last one would be equal rational numbers. Also, at the end of the video, I will explain a question related to Math Olympiad exam. So keep watching. And if you like my video, hit the like button and subscribe to my channel. Also press the bell icon for the notification. So let's get started. Let's start with our first question. Write the rational number in standard form. See, this is a rational number and we have to change it into standard form. And whenever we have to change any rational number in standard form, we have to fulfill two conditions. First condition, denominator should be a positive integer. But in this case, this denominator is negative. So first I have to change this denominator into positive. And whenever we have to change sign of any integer, we have to multiply it with minus 1. So first I will multiply minus 161 with minus 1. But you cannot multiply any one of them. If I am multiplying the denominator, I have to multiply numerator also. So now my answer will be 299 multiplied by minus 1. It is minus 299 divided by multiplication of two negative integer is positive. So it is 161. So our first condition is fulfilled. Now we will fulfill the second condition. And second condition is that there should not be any common divisor other than 1 which can divide 299 and 161 both. And for that we have to divide these two numbers with a common divisor. Now we will find out HCF of these two numbers and then we will divide these two numbers with the HCF. And to find out the HCF, there are two methods. First one is very simple and you must have learned in your lower classes. Second method is division method. Right now I will show you how to find out HCF by division method. First we will make some rough space. First we will find out which one is bigger. 299 is bigger than 161. So bigger number will be the dividend. So now I have to divide 299 by 161. Smaller number will be the divisor and bigger number will be the dividend. And you can imagine that 299 can be divided by 161 for one time only. So it will be 161. It is 8, 3, this is 1. So this is the remainder. This division method is different from our regular division method. In this method, this remainder will become the divisor and this divisor will become the dividend. Now I will divide 161 by 138. So again, it will be divided for just one time because 2 times would be greater than 161. This is 3, this is 2 and this is 0. And still our remainder is 23. Now this remainder will again become divisor and this remainder will become dividend. So now I will divide 138 by 23 and 23. Now you have to calculate, can you multiply 3 with the number so that you will get 8 at one's place? 3 6 are 18. So I can say 23 multiplied by 6. 18, 8, 1. Yes. So I can say 23 6 are 138. But in our regular division method, our answer would be always the quotient. But in this method, our HCF would be the last divisor and last divisor is 23. So our HCF will be 23. Now we will divide 299 and 161 with 23. minus 299 divided by 161. Now I will divide both the numbers with 23. And now I will divide 299 by 23. 23 ones are 23. 6, 9. This would be 3. 69, 0. So our answer will be 13 and sign would be minus divided by. Again I have to divide 161 by 23. You know that 3 sevens are 21. So it may be for 7 times. 7 threes are 21. 1, 2, 7 to the 14, 15, 16. Yes, it is for 7 times. So our answer would be 7. Now there is no common divisor which can divide 13 and 7 both. So now it is in standard form. And again denominator 7 is positive integer. So in this way we have changed 299 divided by minus 161 into standard form. This is the answer. Let's move to our next part, filling the blanks. There are few rational numbers and we have to find out the missing numbers. One thing is very important in all these numbers, that there is a equal sign in between. So it shows that all these rational numbers are equivalent rational numbers. First rational number is minus 9 upon 5 and in second rational number 20 is the denominator. It shows that 5 is converted into 20. The second number is bigger and you know that whenever we multiply 5 with 4 it will become 20. So we can say if I multiply 5 with 4 I will get 20, and you know the rule that we cannot multiply or divide numerator or denominator alone. If I am multiplying the denominator, I have to multiply the numerator also. So again I will multiply 9 with 4 and 9 4s are 36. But sign would be negative. So this is the second number. Third one, 27 is the numerator, but we have to find out the denominator. Again we will start with minus 9 upon 5. We will always start our calculation with the base number, and that is minus 9 upon 5. But this time this 9 is converted into 27, and it shows that we multiply 9 with a number so that it will change into 27, and you know that 9 3s are 27. So again I have to multiply this 5 also with 3, but this 27 is positive integer, but this 9 is negative. It shows that we multiply minus 9 with minus 3. So again I have to multiply 5 with minus 3. And 5 3s are, this is 15. But this time multiplication of a negative integer with a positive integer is always negative. So our second answer is minus 15. Third one again has a numerator. So first we will take the base integer, and that is again minus 9 upon 5. But this time this minus 9 is changed into minus 45. This time 9 is converted into 45, and you know that 9 5s are 45. So we can multiply 9 with 5 and it will become 45. Again I have to multiply 5 with 5 and 5 5s are 25. So our last answer would be 25. In this way we can find out the missing numbers. It may be numerator or it may be denominator, but always start your journey with the base number, and in this case this is minus 9 upon 5. Let's move to our next question. Which of the following are pair of equivalent rational numbers? See, these are two rational numbers and we have to find out whether they are equivalent rational numbers or not. And whenever you have to find out the equivalency of rational numbers, you have to cross multiply them. It means you have to multiply numerator of first one with denominator of second, and the numerator of second one with denominator of first one. So I will cross multiply them first. 3 multiplied by 16 equal minus 8 multiplied by minus 6. 16 3s are 48. 6 8s are 48. And both the negative sign are multiplied, so answer would be positive. And now we can say that these two rational numbers are equivalent rational numbers because cross multiplication of them is equal. Let's move to the second example. Again, I have to find out whether these two rational numbers are equivalent rational number or not. So again, I will do the cross multiplication. So first I will multiply 3 with 4, equal sign, then 12 with minus 1. 3 4s are 12, equal 12 1s are 12. But this time sign would be minus because 12 is positive and 1 is negative. And multiplication of a positive and negative integer is always negative. Both the numbers are same, 12, 12, but signs are different. So we can say that 3 upon 12 and minus 1 upon 4 are not equivalent rational numbers. In our next question, we have to find out the value of x. See, these are two rational numbers and we have to find out this missing number. So first I will cross multiply them. 13 multiplied by x. Then I will put an equal sign. Now I will cross multiply 6 with minus 65. Now we have to find out the value of x. And whenever we have to find out value of a particular variable, we have to shift other numbers. So I will shift this 13 from left hand side of the equal sign to the right hand side. And whenever any number shifts from left hand side to right hand side or right hand side to left hand side, its sign will change. In this case, 13 is getting multiplied, or we can say 13 is at numerator position. So when it will shift from left hand side to right hand side, it will be in denominator position. So x is not getting shifted, so x will remain as it is. Now I will write 6 multiplied by minus 65 divided by 13. You know that 13 5s are 65. So our answer will be 6 multiplied by minus 5, and that is minus 30. So minus 30 is the value of x. In our next question, we have to find out which of the following rational numbers are equal. Equal rational numbers or equivalent rational numbers are one and the same thing. So first I have to find out 8 upon minus 12 and 10 upon 15 are equal rational numbers or not. So again I will cross multiply them. First I will cross multiply 8 with 15. Then I will put an equal sign. Now I will cross multiply minus 12 with 10. Fifteen 8s are 120. Minus 12 multiplied by 10 is minus 120. In both the cases, numbers are same but signs are different. So we can say that these two rational numbers are not equal. Let's move to our last part. This type of question is very common in Math Olympiad exams. To which set of numbers does minus 2.75 belongs? And there are 4 options. First one is natural number, second whole number, third one integers, and last one is rational number. First we will find out this number has a negative sign, and you know that all the natural numbers start from 1, 2, 3, 4 and so on. So it cannot be a negative number. So natural number is not the correct answer. Second one, whole number. You know that whole number starts from 0, but this is a negative number, so it is less than 0. So whole number is also the wrong answer. Third one, integers. Yes, in this case integer may be negative and positive both. You may think that this number may be an integer because it is a negative number, but still it is not possible because integers are whole numbers, positive, negative along with 0, but whole numbers. But this one is a decimal number, so integer is also wrong answer. And the last one, as per our odd one out rule, we can say when all three of them are incorrect, so last one is the correct option. But still I will give you some explanation that why the last answer is correct. You know that rational numbers always represented as P upon Q. But this number is having 2.75 and there is no denominator. We can still put 1. Now I can remove this decimal and put 2 zeros, and now this number will become minus 275 divided by 100. There is a negative sign. So in this way, minus 275 upon 100 is a rational number. So rational number is the correct option. So that's all for today's class. If you like my video, hit the like button and subscribe to my channel. We will meet in my next video. Till then, goodbye. Keep learning, keep smiling.